Welcome back to part 3 of our series on beacon proximity automation. This time, we are shifting focus from PCs to smartphone. We will use our nRF52 BLE Beacon and an Android automation app called Automate, which is easily available on the Play Store. With just a few blocks of logic, we will automate locking and waking up the phone screen based on our beacon's presence. But obviously, that's not it. And with Automate, there are a ton of possible applications you can explore. In part 2, we created something similar for a PC using a Python script. The PC would lock automatically when the beacon left the desk range and wake up when the beacon was detected nearby. We also covered the fundamentals in part 1 of this series, discussing what Bluetooth beacons are and different beacon formats available like iBeacon, Eddystone, and even custom payloads. So if you have missed either of the first two parts, I highly recommend checking them out before diving into today's tutorial. Namaste and welcome to Avinashee Tech, where ideas meet innovation. This channel is all about embedded systems, real world applications, and practical hands on projects that go beyond the basics. If that sounds like your thing, don't forget to hit that subscribe button and tap the bell icon so you never miss out. Before we jump into the phone setup, let's quickly revisit the beacon code. Here in VS Code, we are advertising with no BR EDR flag and 128-bit custom service UUID, just like last time. So nothing much has changed in the beacon's configuration. Now, on your Android phone, head over to Google Play Store and search for Automate by Lalama Lab. I already have it installed. Let's open it up. This app needs admin level permissions to perform lock and wake actions, so make sure to grant all permissions it asks for. I've created a .flow project already, which is specifically for this BLE Beacon automation, and you can download it from my GitHub repository. The link to that would be in the video's description. So once you have your .flow project with you, to import that project, just tap the three dots in the top right corner. Then select Import and choose the downloaded .flow file. Once your file has been imported, tap the pencil icon in the bottom right corner to open the editor and view the entire flow diagram. Let's understand how this works. So there is a plus icon on the bottom right of the screen, and if you tap that plus icon, you will see all the supported nodes. Let's search for Bluetooth and add a Bluetooth device scan node. This is just for demonstration, and I will undo it right after adding it. Now, we already have a scan node in place. Let's explore it. So here, the input arguments allow us to set scan mode, and we have selected active low energy. Then you have option for device type and filters where you can apply certain checkboxes. In the output variables, we are storing ADDR-DEV. Now this is an array of scanned device addresses. Then we have ADV, DEV, and this is the array of device advertisement data. Lastly, we have RSSI DEV, which is an array of all the devices' RSSI values. If we want to know more about what this particular options available are for a particular node, or what a node itself is used for, you can always tap the question mark icon to access the node's documentation directly within the app. Suppose you don't get something in the app, there is also a web-based documentation. On the bottom side, we find that low energy scan is to find beacon. And with the additional active scan option, this app sends scan requests to get beacon data. Then you have the definition for what each input arguments and output variable stand for. So now you know how to understand nodes and their options. Each input and output field is clearly explained. Let's now understand the logic of our flow. So we scan for BLE beacons, and if it is found, all the information of the beacon are stored in the array defined earlier, like device addresses and RSSI data. A decision node checks whether our beacon's address is present in ADDR-DEV array or not. Let's just pause here and talk about identification. On our PC, we used the service UUID for beacon identification. But here, we rely on the device address. Why the change? Well, Automate doesn't easily support UUID based filtering. Believe me, I tried, unsuccessfully. So ultimately, I went with device address matching just to demonstrate the working concept. However, since I'm using a private address, it changes on every reset, which is inconvenient because every time the board resets, I need to enter that private address into these nodes again. So, if you are developing a custom app, you can implement UUID filtering and support private addresses as well. Back to the flow. Once we confirm our beacon is found, we use the index of function. Let's look at its documentation. So this function returns index where value is found in container and ultimately retrieve its respective RSSI value. As we discussed earlier in the series, the device address is part of our BLE advertising PDU or protocol data unit. If RSSI is found to be above the minus 80 dB threshold mark, we keep the screen away and also show a notification message, you are back. If, however, RSSI value is below the threshold minus 80 dB, we display the message, you left your workplace, and then later on lock our device. All right, let's start to run the program. But before running the program, let's make sure that Bluetooth and location are turned on your Android phone and your beacon is powered up. Now, use the nRF Connect mobile app to scan and get your beacon's device address during this boot. Simply run scan, then you will identify the beacon based on the service UUID advertised. Once you find the device, copy that device address into the matching node of our flow. Once done, tap the start button. Right now, the beacon is in my pocket, so after checking all the conditions, the screen stays awake. As I walk away, the signal drops below minus 80 dB and the phone locks. When I return back, the screen wakes up and I just enter my password to log in. You can check the notifications at the top for the feedback messages. Cool, isn't it? So that wraps up part 3 of our series. So we explored the Automate app, learned how to understand and configure nodes in the app, built a flow to lock or wake up our phone based on BLE beacon's proximity, and finally, we tested it using our nRF52 based beacon. If you found this video to be useful, give it a thumbs up, share it, and Do not forget to subscribe to Avinashee Tech for more practical tech tutorials. Signing off. See you in the next video.